Welcome to BuildBytesDaily. You know that feeling when you're writing code and you realize you're basically writing the same function over and over again? One for numbers, then you copy paste it for strings, then maybe again for objects. It's tedious. Well, TypeScript has this incredibly elegant solution called generics. And today we're going to pull back the curtain and show you how to write code that's cleaner, way safer, and a whole lot more reusable. All right, let's get into it.
This right here, this is the fundamental question. Think about it. You've got a function to fetch data, one for users, another for products, a third for blog posts. The logic is the same, right? You make the request, you handle errors, you parse the response. But the types are totally different. And that's where you get this constant battle between wanting to write code just once and also making sure you don't accidentally try to use a product.price on a user object. That's the exact dilemma generics were designed to solve.
So here's how we're going to tackle this today. First, we'll really get into the weeds of that reusability problem. Then, we'll introduce the star of the show, generics. We'll see how to use them, and then how to make them even smarter with something called constraints. We'll take a quick look at where else generics pop up, and finally, we'll wrap it all up with what you really need to remember.
Okay, first things first. Before we can really appreciate just how cool generics are, we've got to feel the pain of the problem they solve. And, it's a pain many of us who've spent time in the wild west of plain JavaScript know all too well.
And this slide just lays it all out, doesn't it? On the left, you've got a function that's super safe, but it only works for numbers. Totally useless if you give it a string. Then on the right, you have the any type. It's the anything goes option. Sure, it's reusable, but you're basically throwing away everything that makes TypeScript awesome. You get no autocomplete, no type checking, you're just hoping for the best.
So it feels like you're stuck, right? You're forced to choose between being safe and rigid or being flexible and, reckless. But what if that's a false choice? What if there's a way to get the best of both worlds?
And this, my friends, is where generics make their grand entrance. They are literally the feature in TypeScript that lets you have your cake and eat it too. You get flexibility and type safety. So let's meet our solution. Okay, look closely at this. It's our same old identity function, but it's got a superpower now. See those angle brackets with the word type in them? That's it. That's a generic. Instead of saying this function takes a number or a string, we're saying it takes some type. It's a placeholder, a variable for a type that we'll figure out later.
So this type variable, think of it like a template. Like in a word processor where you have a spot for your name here. The document structure is set, but you can fill in that blank with any name. A type variable is the exact same idea, but for types. You can plug in string or number or my custom object, and TypeScript just rolls with it, enforcing that type all the way through the function.
So how do you use one of these things? Well, you've got two options. You can be super explicit, like in the first example, and tell TypeScript, hey, I am using a string here. But honestly, the second way is where the real magic is. It's called inference. You just call the function, and TypeScript is smart enough to look at the value my string and go, oh, okay, I get it. Type must be string. It just works. Less typing for you, and your code stays clean.
All right, so passing types around is cool, but what happens when you want to actually use the properties of that generic type inside your function? This is like the first major hurdle people run into with generics. Let's walk through it.
At first glance, this looks fine, right? We just want to log the length. But TypeScript stops you dead in your tracks with an error. And it's actually being your best friend here. It's saying, whoa, hold on a second. This type could be anything. What if someone passes in the number 42? Numbers don't have a .length property. It's saving you from a crash that would have happened later. And the fix is actually pretty simple. Just be more specific. If your function is meant to work with arrays, then tell TypeScript that. By changing type to type squared, we're not just saying it's any old type. We're saying it's an array of that type. And now TypeScript knows for sure that arg is an array, and of course, arrays have a length. Boom, problem solved.
Okay, that array fix was cool, but it's a little restrictive, isn't it? What if we want our function to work with strings too? They have a .length property. Or what about our own custom objects? We need a more flexible approach. And this is where we really level up our game with constraints. So the first step is to define a contract. And we do that with a simple interface. We're creating this thing called lengthwise, and all it says is, look, I don't care what you are, but if you want to play with me, you absolutely must have a property called length, and it has to be a number. It's like setting the rules of the game up front. And now we put it all together. See that extends keyword?
That is the magic. We're now telling our generic type that it can't just be anything anymore. It can be any type as long as it follows the rules of our lengthwise contract. And just like that, TypeScript is happy. It knows for a fact that arg will have a .length property, and our error just vanishes. This is a total game changer. Let's see it in action, just to prove it. If we try to pass in a number like 3, TypeScript says, nope, no length property, and gives you an error. A string? Yup, that works. An array? Of course. And check out that last one. Even a random object we just made up works perfectly, simply because it satisfies the contract. It has a length property. That is the power of constraints right there.
Now, we've been focusing a lot on functions, but I want to be clear, generics are not just a one-trick pony. Once you really get this concept, you'll start seeing them everywhere in the TypeScript world. Let's just take a quick peek. You can make generic interfaces to describe the shape of things. You can build entire generic classes. Take a look at that generic number class. You could use it with the type number, and its add method would do math. But you could also use the exact same class with the type string, and now the add method concatenates strings. One piece of code, multiple type-safe behaviors. The possibilities are just huge.
Wow. Okay, we have covered a ton of ground. We went from a really common coding problem all the way to a super powerful solution. So let's just boil it all down to the key things you need to walk away with.
So, when someone asks you, why should I use generics? You've got 3 killer answers. 1, reusability. You write way less code. 2, type safety. You get to keep all the benefits of TypeScript and catch bugs early. And 3, flexibility. You can build these powerful, adaptable components that are still totally safe. It's the ultimate win-win-win. So now you've got this new tool in your developer tool belt, and the absolute best way to make it stick is to use it. So here's my challenge to you. Go look at your own codebase right now. Find that place where you've copy-pasted some logic just to handle a different type. What's the first component you're going to supercharge with generics? I really hope this look at TypeScript Generics helps you write better, cleaner code. If you found this helpful, do me a favor and hit that like button, and make sure you're subscribed to BuildBytesDaily so you don't miss the next one. Thanks so much for watching, and happy coding.